Stamatios Papadakis said that he will take an hour. So please, let's give him the honor of that hour and just a few minutes for question and answer. And he has promised us an invigorating, hands-on experience. And I think it's the right time for it.
Yes.
In the afternoon. Nobody's sleeping.
Of course.
Definitely not.
It's hard time now.
It's computational thinking and coding skills. And I think if you think about the computational thinking and coding skills in early childhood education and care, ECEC, University of Crete, Greece.
Exactly.
Thank you so much.
You're welcome.
Okay. Please go ahead.
Hello everyone. Let me again introduce myself. My name is Stamatios Papadakis. I'm an assistant professor at the University of Crete, the southern part of Crete. Again, I would like to thank you personally, Vincentas, for the invitation coming here, and all of you for your attention and your patience for this 2-hour workshop. I know the time is hard, always hard, when you have to hear someone for 2 hours, but I promise that I am not going to speak a lot. Instead, I'm going to make together with you some hands-on activities using your mobile phones. Okay, if you don't have phone and you want to participate, you can use my computer instead of me. Okay, no problem at all. We will take the part of the young children or even my university students which are novice programmers. They have no prior experience with coding, with algorithmic thinking and so on. Also, the majority of them, 99%, are female students, so they bring with them the stereotypes regarding their role in ICT and coding and so on. So do not afraid if you have not previous experience with coding. These workshops reflects to novice programmers. Okay, before start the presentation or the workshop, some things to consider about why fostering computational thinking, coding skills, algorithmic skills are too important, not only in higher education or in secondary education, but also in early childhood education. First of all, it's very important to continue the previous conversation regarding the new curriculum. European Union forces us to introduce now new curriculums. Very early, at the beginning of the previous month, May 25, EU published a call regarding basic skills. In this call, you can read that the European Union recognized the development of basic skills as fundamental part for the European Union in order to promote better educational systems and later on active citizens to work in the society full of AI applications, machines, and so on. These skills, under the umbrella of basic skills, are considered literacy, numeracy, digital competence, and any other competencies that we are called 21st century skills. And this is very important that all these kind of activities and skills can be cultivated even in the early childhood education. And this is very important because in the previous decades, if you can remember Piaget, some pedagogists claimed that all these kind of activities, and especially programming, was too abstract for the young age children to work with it and to understand these kind of notions. But now, we believe that children, when introduced properly with the preferred tools, like apps and of course approaches, they are able to introduce themselves with very good results in these skills. So, later on, I'm going to discuss with you another idea that has been developed in the United States the last 3 to 5 years. Instead of computational thinking, some very famous researchers are talking that we have to cultivate to children of all ages computational fluency. And this is something that we are going to work here. So, what we know first of all regarding the computational thinking. It's the development of computational thinking has attracted increasing attention, especially in the last decade, based mostly on the latest development of EdTech. And this is very important because now computational thinking is considered as a new literacy. A lot of researchers around the world are supporting the idea that together with 3 R's, read, write and arithmetics, we have also to introduce children in algorithmic, the 4 R's. They now discuss about the 4 R's. And as already support the idea why it's so important. If we want to clarify what we mean with the term computational thinking, we can say in a few words that CT can be considered as a general problem-solving framework. And in this framework, our students are able to think, to reasoning, and of course, to anticipate various problems. Imagine that the same idea is exactly the same what now the AI companies try to make with their AI tools they create. For instance, OpenAI promotes the latest AI models like O3, that it's a reasoning model. They start thinking now, not just copy-paste information or generate information. So, exactly the same we want for the young age children. We want to make our students capable of reasoning and not just reproducing information. Instead of being digital consumers, we want now to be digital creations since the very first years in the typical educational system, since the years of kindergarten. And of course, in terms of computer science, when we are talking about CT, we discuss about sequences, conditionals, operators, and variables. Okay, now we discuss about the idea of computational fluency, I spoke earlier. Because many researchers, and the most famous of them is Mitch Resnick, I don't know if you're familiar with him, he is the creator of Scratch. He is a professor at MIT, Technological Institute of Massachusetts in the United States, says and supports that we must not only introduce children in simple coding activities, solve this, move a robot in a labyrinth and so on, but we must cultivate their computational fluency. What means with that? It means that the children must be able to express themselves. Like the pedagogy says, they must work in an empty canvas, like a painter, and must have the necessary abilities to express what they are thinking about in projects that they have meaning for them, meaningful projects. This is what they call computational fluency, and later on you see how some apps promote computational fluency, while some other apps simply promote computational thinking skills. Okay, and for instance, to better understand the idea of computational fluency, here Mitch Resnick gives a paradigm regarding computational fluency. For instance, if we put some blocks together, no matter if they are digital or if they are hands-on, maybe we can help them develop their basic computing and coding skills, but in fact it's missing an essential part of how they communicate with the machines and so on. For instance, if we just give them puzzles or apps like move a robot to a labyrinth and so on, it's the same idea like to try to teach them by writing, by only teaching them grammar and punctuation. Simple commands. It's the same idea. Instead of that, or in terms of literacy, it will be like the same idea, like giving them crossword puzzles and expect from them to learn to express themselves effectively. This is the wrong idea how many people try to educate students coding and CT skills and activities. And instead of that, we have now some better apps and approach to help them, our students, to develop what we are calling computational fluency. And another very famous researcher from the Boston College in the United States, Marina Bears, later on you will see he is the founder of Scratch Junior, use another paradigm. This is a playpen. Says that when we are using with our children, not only in early childhood education, but also in primary education, when we are using, for instance, apps or activities that simply ask our students, do this and then do this and then do that, we simply, it's the same idea like using babies in a playpen. You can see here in a playpen, a child can play but is protected, cannot express themselves. On the contrary, what we have to do when we are teaching coding activities in early childhood education, but also in primary education as well, we have to use not a digital playpen, but a digital playground. Imagine the idea as a playground in a park. The children are free, they can play whatever they want. Maybe they can hurt also themselves, not so hardly, but this is the idea. Marina Bears is calling that hard fun, because in the hard fun, children learn to express themselves. And also the same idea is when we introduce coding activities in children. We leave them alone in a digital canvas to try to express themselves, even with a lot of mistakes. But through the mistakes, they also learn how to debug their projects. And this is also very important to cultivate abstract skills. Okay, what do we know regarding the international research? Unfortunately, we have learned that there are, in the two famous digital tools stores, for Android and app and iOS, we have a problem. We have plenty of tools and apps promoting that there are super duper apps to promote city skills and so on. But unfortunately, many of these apps have never been evaluated. This is another problem of digital apps. It's very easy for someone with a little knowledge of coding to create an app and upload it and promote it. This is very easy because we know that the digital market is unregulated. And imagine that if that was easier 2-3 years ago, how easy is now with new advanced AI tools which can create code in a few minutes. So, we have a problem. We have many apps, most of them are unregulated. They just promote it as educationals, but in fact, they give no real educational value to children and their teachers as well. For instance, here is an example of the most famous apps for young age children. When I mean young age children, I mean children from kindergarten, pre-kindergarten, kindergarten, and first and second grade of primary schools. For instance, this is a Scratch Junior, this is codable, if you are familiar with that. This is the Daisy, the Dinosaur, and this is the Bib, not the Bibot, the Lightbot Junior. You can see that the majority of these apps do not support all the necessary skills and notions that children must learn when they are teaching coding and computational thinking skills in kindergarten and also in the first grades of primary schools. You can see that, in fact, none of these apps is perfect. And the majority of these apps do not support all the basic skills like abstractions, algorithmic, decomposition, parallelism, and so on. The same here. And of course, what is also important, just to recall Vygotsky as a great pedagogist, and social interaction, and scaffolding, and so on, you can see here that, in fact, none of the apps do not support peers collaboration. All the apps have been created for the child to work alone, although the pedagogists all the time call for peer interaction in our education system. So, you can see that, although later on I'm going to speak about this app, I also want to say that this app is better than others, but it's not ideal. It's not the best app. It needs serious work to be done also, but compared to other apps, has a lot of advantages, and this is the reason that we introduced this app in various educational systems across the world. But it's not the perfect. Still, a lot of work needs to be done. Okay, that's the theoretical part, because I know you are too tired. Before going to hands-on activities, I'm going to speak very shortly regarding this specific app, which is called Scratch Junior, just to see what it's about, and later on we are going to programming it. So, first of all, this is the famous character of the Scratch Junior. If you are familiar with Scratch, are you familiar with Scratch? No. Okay. I will explain you what is the connection between Scratch Junior and Scratch. Scratch is the best educational app to promote coding skills to novice programmers, but from the age of 8 years old until 99 years old. This is the logo, the promo of Scratch if you visit the Scratch site. But when they created the Scratch and realized the popularity of the app, realized also at the same time that Scratch is not suitable for young age children because it's heavily based on text. Young age children cannot read and of course cannot write. So they need a different approach. For that reason, based on the positive outcomes of the Scratch, the same researchers designed a new Scratch orientated for young age children. So they called it Scratch Junior. So if we want to make a path, a learning path, what we are using now in many educational systems, also in the Greek educational system, because now we have also a new curriculum. For instance, in kindergarten and the first 2 years of primary schools, we introduce our students to Scratch Junior. Later on the primary school and the gymnasium, lower secondary school, we introduce them from Scratch. And then in the higher secondary schools or lyceum, we introduce them to Python. So this is the path from block-based programming to a textual programming language. And of course, with educational robotic activities like microbit, raspberry, and so on. Okay, this is a small video. We are not going to see that because we are not going to work. Okay, so what we try to do when we are introducing Scratch Junior or even any app to young age children. First of all, we want children to gain a better understanding of mathematics and literacy, because now coding is anticipated as a multidisciplinary approach and not something isolated in a computer lab. Secondly, we want children to become familiar with classifications of other computer software and mathematical components, to be able to express themselves and to handle adequately smartphones or PCs and so on. Also, we want children to build foundational knowledge structures across various learning domains. And finally, and it's also very important, to become better problem solvers and thinkers. This is very important. And it's also very important in the age of AI, because we don't want students to just consume the response of AI prompts. We want to think systematically of these prompts and to evaluate them before using them. Because many people, I mentioned that because many people now believe that based on the capabilities of AI tools, programmers are going to become obsolete. This is completely wrong, because we always need programmers and people to be thinkers so as to try to understand the responses of AI tools, to recognize the hallucinations of the AI prompts, and so on. So, instead of this ability to become obsolete, now, based on the age of AI, it's even more important than before. But unfortunately, many people do not recognize that. Okay, I have already explained what is the main idea of Scratch Junior, and I have spoken already about that, just to mention that. Another difference between this is the Scratch, the main character of the Scratch, and this is the main character of the Scratch Junior. You can see this is more childish, more child-friendly, because it's oriented for young age children. Another better advantage for Scratch Junior is that Scratch Junior is optimized for mobile devices, tablets and smartphones. I remember that you mentioned that we, in the schools and in the universities, sometimes we follow the bring your own device approach. I am calling also my students and in the kindergartens to follow the bring your own tablet approach, because this app is optimized for tablets. And why it's so important? Because we know that the physical interaction of young age children is not with mouse and keyboard. These tools are not ideal for them, but the physical approach to interact with device, it's with their hands. So, a screen-based app supports this physical interaction. So, they created this app to be optimized for smart mobile devices. Also, is that this app do not support the use of extra keyboards and mouse. But in case we need to add some numbers, has a digital embedded keyboard. For instance, we are going to see this later. This is the way children are programming with this app. You can see that there is no text, there is no need to write something or to read something. Children just, they have to use their hands and to move command blocks similar like they connect puzzle. This is very easy for them to do. And also, you can see that there are 6 different categories of command blocks. We have trigger blocks. When I press something, do something. We have sound blocks. You can see that this is very interesting because, as I told you, we want students to express themselves so they can speak and to hear their voices. This is very important. Of course, we have motion blocks to make a character move, jump, turn around, and so on. We have some more advanced commands. You can see here is the repeat. We can introduce the children to learn how to make a character do something many times. This is something that Piaget in the 60s supported the idea that this was too complex and too abstract for the children to work with this idea, and Piaget has supported the idea that children should work with this kind of commands when they have finished the primary school. But now we have learned that with the proper approaches we can introduce the repeat commands even in preschoolers. And it's very based on my experience when I'm working with children in the kindergartens. After a few lessons, it's very easy for them to understand and of course to work with this kind of commands. Also, we have some other tools that children can make a character to appear, to disappear, to become bigger, to become shorter, you know, so as to make nice projects for them. And of course, we have commands so as children to make a project like a book, so they can make different pages of their stories, they can move between the stories and so on, the different pages, sorry, of the stories and so on. And what is also important is this one. These are the command blocks in Scratch. Remember that Scratch is oriented for for older students. This is exactly the same commands in Scratch Junior. You can see the difference. Not text, here there is text. Here there is no text. Also, you can see that they are child-friendly, this kind of commands, and so on. So, you can see that everything is designed, not accidentally, but with focus on how young age children must learn and they want to learn. I mentioned that just to repeat what I said at the first slide, that although there are many apps in the various markets, some of them cost a lot of money. Unfortunately, they are not created, they have not been created on based on what the psychologists support regarding how young children learn, how the blocks, how the colors of the blocks are friendly for the children, and so on. Okay, this is the interface of the app. You can see that the whole interface of the app is completely user-friendly, and also it's very minimalist. There is no information which is not useful for the children. Here the children can take characters. You can see they have just the necessary text, just cat, dog. Here is the scene, the children put the characters to interact. Here is the programming area. Later on you can see how we program it just with that, just drag and drop commands. And of course here is a full story. A full story in the Scratch Junior consists only of 4 pages, not much more. And the reason is because they don't want cognitive overload young age children with too much information. They just want, the creators of the app, children just to create simple projects without missing themselves in multiply pages and information. They just want to create simple projects. Okay, what is also important, and you are going to like it, based on my experience with my students, is that Scratch Junior, it's contain a paint editor. So what it means, and why it is so important for the children? Because when we use a pre-made character, children can visit the paint editor, and you can see here the colors and the other tools can create a completely different character based on their interests and their idea of what their project would like to be. And also, I'm going to work with you with an extra ability. You can see here there is a camera. A children can take a photo of himself so as to create a character like himself. This is very important because this is what I spoke earlier, for computational fluency. We want children to express themselves via the projects. Also, I spoke already for that, we have a recorder machine. Children can record their own voices to create their own stories. And if we want to talk about how Scratch Junior now supports what European Union call for basic skills and key competencies, you can see here that while the children are working with various examples, at the same time, this app supports all the competencies that European Union asks for the educational system to support. This is very important. And this is the reason why the Greek educational system, in our new curriculum for kindergarten and primary school, we have adopted Scratch Junior as an app for kindergarten teachers and primary school teachers to work with. Okay, we have already discussed this. Yes, this is important. Now I'm going to tell you how I'm working with my students in my university lessons to introduce them in Scratch Junior, to help them learn coding and then to teach coding to preschoolers. First of all, I have collaborated with Boston College and MIT in the United States. Boston College has created curriculum. I'm going to see towards that. The curriculum is called CAL, Coding as Another Language. We have get the permission to translate and adapt this curriculum in the Greek settings. So we have a curriculum with 33 lessons. You can see here in Greek says kindergarten, first class, second class, primary school class. We have created two different books. This is a fiction book, a story about a rainbow fairy, and this is a fiction book regarding Hypatia. I don't know if you're familiar with Hypatia, but I expected that. But Hypatia was supposed to be the first female scientist in the humanity. She was very famous. He created a lot of artifacts and theories. He lived in Alexandria in Egypt during the first century after Christ. And this is the reason that the Christians killed her, because she was not Christian. She believed in the ancient Greek gods, Apollo, Aphrodite, and so on, and they killed her. But why I choose that? Because I want to introduce my students, which as I already mentioned that in their majority are female students, that, or to forget the stereotypes regarding the gender roles, that female students are not good in science or in STEM activities or in coding, but I want to learn that even in the ancient years, women were pioneers in STEM activities in this year and so on. Because also the app, you will see that it's gender friendly, does not promote the males, but both genders. This is very important in order to fight the gender stereotypes. Also, we have a book regarding Scratch Junior, translated from the English language, which I'm using. And this is another book I have created with theory and also a lot of examples how to use Scratch Junior to introduce children various concepts like triggering, debugging, event programming, and so on. And let's see if I can. Okay, I can now because it's open behind that. Do not change them. Later on I'm going to see you to the CAL approach. Okay, later on if you want to find some better information on regarding the Scratch Junior. In fact, we have finished, but before finish that, my presentation and working with Scratch Junior, I have forgotten, or I want to mention some more advantages regarding Scratch Junior. So, except all these advantages, another advantage for, especially for the Greek educational systems, is that this app, although very good, supported by famous universities in the United States and worldwide, it's free. This is very important. Everyone can use this app for free. Also, this app is supported with educational material, which is also free. This is very important, because I don't know about your schools, but our schools in Greece, they do not have extra funding for buying licenses, software license. Maybe they have tablets, especially after the pandemics, they have computers, but they don't have money to buy license, software license. So it's very important that there is an app which is free, completely free. Another example, another advantage is that this app, you can see, it's free and it's also available for Android devices and also for iOS supported devices. So we have an app which is free and supports all smartphones and all tablets. This is also very important because, for instance, there is another app which, okay, it's a bit okay, Daisy the dinosaur, but unfortunately supports only Apple devices. So, for instance, in Greece, the majority of the devices are Android based, so we cannot use that app. And of course, as I already mentioned, there is free of educational material available in the official Scratch Junior website, which we are going to see now before starting working with the app. Okay, so we didn't finish, do not applause, we are going to work, okay? So, here, this is the official website we are using, and in this website, you can see, first of all, this is Marina Betts, Dr. Marina Betts, one of the founders of the and here, for instance, if you press kindergarten, you can see here is all the pedagogy of the app, of the curriculum, what supports, how is created. Of course, this is Greek, but, and of course, you can download everything with the necessary, it's a bit, okay, before, and also, here, this is most important for you. I suppose you don't understand the Greek language. If you visit here the curricula, you are visiting the English side, which is most important, but also what is most important, you can see here that various universities around the world have worked with Boston College and MIT, and we have translated the CAL in various languages, in Spanish, Israel, Turkish, Greek, of course, Portuguese, and I know that other universities around the world trying now to translate and adapt this curriculum in specific country settings. So if someone of you is interested in this endeavor, you can communicate with me to tell you how you can get the rights. Everything is free, so as to translate this curriculum in your own educational settings and so on. So, after that, let's see where we found this specific app. Sorry. If we just write on the Google Scratch Junior, this is the official site. Let's see what is the official site. You can see, first of all, from here, you can download the app on your mobile phones. You see, you have the option for App Store, for Google Play, and so on. Also, here you can see that there is educational material, so as very easily you can introduce yourself in this in the interface and the capabilities of Scratch Junior. Also here there are ready-made activities, so as someone, a teacher or even a father, we use this approach during the pandemic. A father can download, not a father, a parent, because we are gender friendly here, and can download this activity, and you can see a child can make alone with the help of an adult an activity. You see how little cognitive volume need for a child to create an app. For instance, this app make a car moving in a town. You just need to use 3 commands and a character. So easily. And of course, and something which is also very important, here you can see there is an option called Scratch Junior Connect. If you visit that, there is a library of ready-made apps. So, a teacher or a parent can visit this app and find ready-made projects from various teachers or researchers around the world, download this for free and use it to his or her lesson. This is also very important because you may have the experience that many other apps or software tools are having, for instance, educational materials, but it's not for free. Here, everything is free. The app, the educational material, the projects, everything. This is very important. You do not have to buy anything. No license, no books, nothing at all.
Is it open source?
Yes. Who asked that? You. Yes. This is something very important. I'm going to highlight this now. This is open source. This is meaning that if you want, you can take the app and adapt it. Maybe you can work the app with extra capabilities if you know how to program in Java, for instance. Yes, but based on this, this is something very, very important for me. Some people are asking me that, okay, in my kindergarten, I do not have enough tablets, but I have enough PCs, computers. How can I work with Scratch Junior when you are talking about mobile devices? based on that Scratch Junior is open source, some programmers took the app, took the official app, and make an app who works also in computers. So imagine we have a free app who works on Apple devices, on Android devices, and we have also an app who works on computers. So everyone, everywhere, with every device, can work with this app. As far as I know, there is no other app who gives these opportunities to work with it for free, of course.
So
You
how do they survive this company?
Yes. First of all, it's not company. It's university. It's the Boston College, the Tufts University, and the MIT in the United States. Last week I was in Boston, in this office, because we work on a prototype to integrate Scratch Junior with Microbit this time. And they have sponsorships from large companies and also from the
National Research Foundation.
from the National Scientific Foundation in the United States, or in general from the American government. But unfortunately, they told me that based on the Trump, when I was there, they cut 5 million of just in one night without explanation.
Deal.
They just were informed that no more money. Yes, but I asked them if they plan to ask for a small donation or for the users. No, they told me the app is going to be free forever.
It's very generous, actually.
Yes, yes. And here you can see how you can download the app for Mac devices, and of course for Windows. And here, we don't need this anymore, or this, or this, or this. Okay, here you can see when I download the app in my computer, this is the app. Here, you are going to work with your mobile devices, but just for the presentation reasons, I'm going to work with my laptop. They have exactly the same capabilities, no problem at all. And this is also very important. So, in order to start the workshop now, for the next hour, just try to connect to Wi-Fi network instead of using your mobile data, and visit Scratch, visit Play Google or App Store, it depends on your operating system, and write Scratch Junior and try to download it. If you face any difficulties,
It works,
yeah, okay.
at least for my Android.
Okay, if you face any difficulty, just tell me to help you. Scratch Junior, one word. And then you can, when it is downloaded, you can open it. Do not afraid, the app is completely free, no virus, no GDPR issues, do not ask for everything. Also, imagine that this app, if you see carefully, writes beta. Beta, the app now is in beta version the last 12 years. And when I ask them why you write that this app is in beta version, because they are not feeling confident that the app is working properly or it's the best interaction for the young age children. And this is very, very interesting if you think that, as I told before, there are programmers who create an app in a few hours and sell it as educational app. Whole universities are working in an app for 12 years now, and they are not feeling confident for the app, but a person is creating an app in a few hours and advertise here as super educational app. This is just food, something to consider about. So, also, if you install the app, on your mobile devices, if you go here on the gear, you can choose the language. You do not have to work the app in the English language. This is also very important. You can choose your own language. Lithuanian, I suppose, is supported, Latvian is supported, Polish, and so on.
No, Lithuanian is,
No?
no, not in the list.
Really?
Yeah.
I thought that usually all the apps do not support the Greek language because as a market, we are a small market. But now I learned that Lithuanian also
Yeah,
is a small
smaller.
market.
Smaller than-
But you can make a request to them to translate it, the app. Or if a university in Lithuanian educational department wants to translate it, they are free to translate it. Okay.
But Italian.
Okay, if you are not having the language you prefer, we are going to work with the English language. Okay. Okay, here you can see if we go to the house in the home page, you can see the projects you have created while working the app. Your area is empty, I suppose, because this is the first time you have downloaded the app. But during the semester, I have worked with my children, my students, to create some apps. Some of them are very simple, some of them are more complicated. For instance, here, we work with my students to create an app to move this beer in a labyrinth. This was a project to help children, first of all, to learn some basic skills in coding, but also to try them to cultivate their spatial skills and their motion skills. And again, if you press the home button, you can go in another app. For instance, let's see an app. First of all, you can see here an astronaut. If you see the face of the astronaut, it's my face. I took it a photo. This is what I told before, that children have the ability to take a selfie of themselves so as to feel more familiar with the project. Okay, so with my students, we call this app Apollo 14 from the movie with Tom Hanks. Let's see what this app is doing. Sorry. I do not have. Okay, I have sound. Perfect. See. Here I was supposed to have sound, but it's not. There is a reverse count, 10, 9, 8, so as to help students learn to count, so as to combine coding with arithmetic skills. Here is here it says the names of the planet, Moon, Aphrodite, Saturn, Earth, and so on. and this is meaning end. This was a story my students want to create together, but this is a nice example how, for instance, within an app you can combine literacy, they write a word, numeracy, they count reverse, science, they learn the name of the planets, and of course various other skills like even this one, paint skills. This was a character, and they, with the help of the paint editor, they created like the earth. Okay, so now let's try together to make an app. Okay, we are going to make some very easy app and maybe another more advanced. Okay, so if I press again this button, I'm here in my gallery, okay? But if I want to create a new project, I'm pressing the plus sign, okay, and I'm here. Okay.
We are here.
So, one difference with your app and my app is that
The cat.
exactly, you have a cat. I do not have a cat, I have like an aubergine.
No, we have an aubergine.
Yes, he is correct because he is working with a laptop, with a PC. Yes. Why this happening? When you are working this app, because it's not the official app, but it's an app open source, they have changed the main character. Instead of the cat, they use an aubergine. But this is the only difference. The app in both devices are fully functional. There is no problem at all. Okay, so, but in order to work all of us together, look, if I don't want this app, I can move my mouse in this app, count for 2 seconds, and you can see a red X. If I press it that,
How is possible to delay the story?
later on. Okay, so if you delete the character by mistake, you can recall it here. You can undo it. Another way to delete a character is from here. You go here, just again count for 2 seconds. 1, 2. You see again the same X. And now this is what the pedagogists are calling a canvas, a white
So how do you
canvas.
do it on a phone? 'Cause I don't have a
Yes, I
mouse.
forgot it. Instead of the mouse, you use your finger.
Okay.
Just press your finger.
Okay. Yeah.
Okay, so now we are here. Everything is completely empty.
Tabula rasa.
Exactly. Tabula rasa. Yes, a white canvas. What the Kostrunic approach supports that children have to work with. So, from here, we have to decide what to do, or a children to decide what to do with his project, so on. Let's see. If we go here in the plus sign, you see here in the plus sign, you can see a ready-made, you can see here a gallery of ready-made characters. You can see.
Yeah.
Okay. What we are going to create, we are going to make a race between 3 animals to see which animal is going to win. This is a very nice introductory activity and the children love it. So, because what we want children to like it. If children do not like an activity, they are not going to work with it. And it's exactly the same approach I'm using with my students. If my students do not like it, do not feel confident with this kind of activities, okay, some of them will try to pass the exam lesson. The majority of them not. But the main problem for me is that afterwards they are not going to introduce the same kind of activities in the kindergarten. So I am trying to introduce them with playful activities, easy activities, so as to be happy to work with them with this kind of activities later on. So, for our activity, we are going to use this dog. One of the three animals is going to be a dog. I am choosing the dog. You can see here also, when you choose a character, the name appears here. This is a connection between literacy and coding to help children combine the dog with the dog, the letter. And then, what I'm doing, I'm pressing this sign. You see that? This sign here. And immediately, the dog appears in the screen. Someone maybe tell me that do not like the color of the dog, wants to make it seems different. No problem at all. If I'm going here, you can see a paintbrush here, and press that. This is the embedded paint editor. So here the children
How are you?
can go and change everything. For instance, how I went here. For instance, here, a children might like the dog to be like that.
I listen.
Or maybe wants to be something like that. We don't care about them because I told you we want children to express themselves. So they are free, completely free, to modify the characters. So, I don't like it, it's too black. Okay, this is better. Also, you can see here, a child may take this tool and make him like a cat. To hear?
He's becoming a cat.
Yes, yes.
Oh, I've never seen a mixed cat like that.
Or,
You are transforming into a cat.
okay, something like this. Whatever he or she wants. And if we are happy with that, we press this button. And now, remember how was the character in the beginning? Now we have a new character based on our interests and needs.
Or under control.
Then we can move the character in every place in this area. Let's try now to introduce a second character. But this time, I want to create an animal that does not exist. An animal I have imagined. So, the children can now, instead of choosing one of these characters, can go here. You see? Here is an empty character. And press again the paintbrush button, and now he's in an empty character. The children now can, for instance, take this button and this one. I will try to make
Yeah, this is like paint.
Yes, it's an embedding paint editor which helps students again to create their own projects. Okay, this is a new animal.
Where's the sweets?
Let's make it,
I need sweets.
let's make it like, in any case, okay. Okay, so, this is the second animal. We can move it.
Can you draw with your finger? Because my finger is not drawing.
You can. Maybe one character is
Okay.
below the other. If you move it a little,
Okay.
you can move it. So,
Found it.
what we have now, and let's put another third animal. Now, okay, see, we have a character, we have modified it. We have a character we have created from scratch, and we have a character from the library. This is very important. When I was working with my PhD and later on with my postdoctorate, I created educational apps. Not for selling them, otherwise I will not be here, I will become rich. But I had a problem. For instance, those years, 10 years ago, I was programming with Flash, if you are familiar with that. Flash was the best multimedia project in this category. Everything in the web, all the apps were created with Flash. But in order to make a character to move, you have to program it with a very difficult language, ActionScript 3. Now, this app, based on my experience, it's much more powerful than this professional tool, which costed 5,000 euros to buy it, the license. Also, when I wanted to introduce some characters in my apps, I had to find them in the internet, or much worse, to buy them from the repositories, from the images repositories, because of the rights. Now, here, I don't know if you mentioned that, but we have an app ready with app characters, so we don't have the need to look on external sources for characters, images to buy. This is also very important for the teachers and for the developers. So, now we have introduced 3 different animals in our application. Okay? But the scenery is not so much nice. It's empty. It's white. Let's now try to introduce a nice background in our application. If I want to insert a background in my application, you see this button here? If you press it, you have ready-made backgrounds. For instance, for our arrays, we are going to use this background for the animals to run free. I choose this background and I'm pressing this one. Again, I repeat, if I want to introduce a background, I am pressing this button, and from the library, I am choosing the background I want to use. And again, if I want, I can take a background empty to work with it. This is very important. Or I can take a ready background and modify it. You see, for instance, in an app we created with my students, we want to create an app for the students to see the difference between the different time periods, morning, afternoon, and so on. So what we did, we create the same app, but for its different time, we use the same background, but with different horizon. For instance, for the evening, we use something like this. Later on, for the early morning, we use something like this. For the evening, we use something like this. This is a very nice opportunity, both for teachers and for students. Very easily to modify their projects based on their needs. And again, I highlight teachers because again, if teachers find this app is difficult for them, they are not going to work with the app. If they find it that it's very easy, as they told me on their reports, they are very willing to work with it.
Is it possible to upload the image for background?
No,
No.
but you can do something else. Thank you for reminding me that. For instance, what I can do is this one. I'm going here in an empty background. And what I'm doing, I will go here and I will paint a rectangle. And with this one, you see the camera? I hope my camera to be enabled. I don't know why it's not enabled, but maybe your camera with your mobile phone is going to be enabled. No, it's not working now, but you can take a photo.
But you only can take a photo. You cannot upload
No,
from gallery.
for security reasons, you cannot upload. It's for security reasons. Yes, now it's working. You see, for instance, I can take my camera. Now, and the background is this image of the class. And I have created an app with a specific background. This is very important when we are going with children outside, in various activities outside the classroom, and we are using our tablets, and they can take photo real objects of the real world, and then transform their experience in an app. Imagine that. And of course, what else I can do is this one. I can take a character like the astronaut. You remember the astronaut? This one. I'm going to go here, and if I put my mouse, my mouse in something that is closed schema, you can see. This is the astronaut. You can do exactly the same with your mobile phones. Again, I'm repeating the same. Everything is made for the children to make themselves familiar with the app and with the projects they create. Okay. I do not want the astronaut. I'm going to erase it. You remember how? 1, 2, and erase it. Also, I don't like this animal. I'm going to erase it. I don't like the dog. I'm going to erase it. I don't like the background because it's not so friendly.
Is it possible to erase Paolo?
No.
Okay, and I'm going now to use 3 different animals. The dog, okay, a dog, a pig, and a fly. Okay.
Doesn't run on the ground.
We have now 3 different animals. Let's now try to programming them to do something, because now we're just playing. We have created the characters, the background, but there is no action. Okay? So, This is now the nice thing, because to programming them, it's very, very easy. First of all, but also very difficult. This is the most common error my students are doing. What is the common error? And I hope you are not going to do that. When I want to programming the fly to do something, I must be sure that I have selected the fly. You can see here that there is an orange rectangle. You can see here that it's more highlighted. The other two animals are not highlighted. So, if I see that this is or this is highlighted, now I am sure that I have selected the correct animal, the correct character. Also, I can see it here. You can see also here the fly. So, I have three different ways to become sure that I have selected the right animal. But what my experience says, all the time my students are selecting their own animal. They are not so careful, and they maybe want to programming the fly, but they have selected the pig. And it is not a problem. The problem is that they expect the pig to do something else, the fly something else, and so on. Okay. Just to summarize, you are in the same condition. You have introduced a background and three different animals. Okay. Now, we are going to programming them. What we are going to do? We are going to make a race between the three animals. And when I am pressing the green flag, this is going to be the triggering event. The animals will start to run, and we are going to see which of the three animals is going to finish first. But how we are going to do that? It's very, very easy. Well, first of all, I have selected the fly. I am going here in the yellow button, and you can see here 1, 2, 3, 4, 5 different buttons, command blocks, more specifically. This is very easy. You understand what it's doing? It says, when I press the green flag, do something. Here it says, when with my hand, my finger, not my hand, I am pressing something, do something. And this one, it says, when two characters collapse, do something. This is very nice when I want to make dialogues between the characters. Imagine that two characters are walking from different positions, they meet each other, and they are talking between them. This is happening with that. When a character meets another character. And this is also very nice, because with this button, I am doing interactive apps. Because this app is doing something when the child is going with a finger and press it. So, we have three different options to interact with an app. These also are very, very useful tools, but they are more advanced. It's broadcasting. If you know about broadcasting in various programming languages, I'm not going to discuss it now with you. Maybe in another conference, when you are more familiar with Scratch. So, what I want now is, when I press the green flag, so I'm taking this button, and with drag and drop, you can see, drag and drop, I'm leaving it here. So, this is my first command. Let's see what's happening when I press the green flag, or you are going to tell me what is going to be happening when I press now the green flag to the fly.
Let's just change the highlight. Nothing more.
Yes, that's true. That's true. You can see nothing more, because there are no commands here. I tell him pre-prepare. When I press the green flag, do something, but what to do? There is no extra command. Okay, what we are going to do now? I'm going here in this orange thing, here. With my mouse or with my finger, I'm pressing this one, this thing, the orange thing. Okay? Here you can see a very nice command block. This one. I'm going to take this one. I'm going to take this one and I'm going to put it here. You see, if you look carefully, you can see a shadow effect. This is especially made for the children to realize that they connect blocks in the same idea as they play with puzzles. You can see. If they try to connect it on the other side, nothing happens. So in this way, the children understand that only this kind of connection can be happened. So, in this approach, the scientists, the computer sciences, says that with this approach, with block-based programming, we avoid the syntax errors, which if you have the happiness to work with Java, or with Python, or with any other textual language, this is the most common problem we face. If we write a command on capital letter or in small letters, nothing works, and you don't know what's the problem. Or if you forget a comma or a semicolon. Here we don't have this kind of problems. We just connect command blocks in the same idea, in the same way as the children are playing with puzzles. So the whole interface, after a few minutes, it's very familiar to them. And this is what we want. So here you can see an arrow. If you press the arrow, this is something very nice. We have 3 different modes of how a character is moving. This is moving slowly. This is moving normally, and this is running. So, if we play with these properties, we can make a race between 3 different animals. Each of the animal has a different mode of walking, of running, and so on. So, for the fly, we are going to use the very fast way. Let's make the very fast. And then we have to go here on the blue family, because here are the motion blocks. We have to tell now the fly to move, and usually we want to move from this direction to this direction. So we are going to use these blocks. This is also very important because now the children learn the spatial ability and to recognize the different directions. So, look, for instance, if I take this button and press the green flag, I can see that now the fly is moving, but it's not moving far away. I have now to reset the fly in its initial position by pressing this button. You can see this button. The fly is returned. So, we are asking now the children to think, to reason, how many of this kind of blocks are needed for the fly to move here. So, how many you think?
5.
5. Perfect. 5. 5. The first child said 5. No problem at all. So, we ask for the children to take 1, 2, 3, 4, 5 blocks, as Paola said. But maybe this is correct, maybe this is wrong. This is not our problem at this time. I want to see now the connection with early numeracy, because with this question, children now combine coding with mathematics. This is also very important. And now we are going to learn another concept. Now, as a teacher, I'm telling the children to see if the 5 is the correct number. Again, I am pressing this, okay? Okay, the fly is moving, but it's not moving enough, correct? So, this is the debugging approach. The children realize that this is a fault decision, and we are asking them again to think for the correct. Maybe another children says 10 and 9. Okay, we are going.
And we had.
Exactly. Exactly, 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 exactly.
May I ask, do the children get bored doing this?
No, no. Believe me,
Really?
no.
Because when you look at the games and how they play and how fast that game is, I'm thinking of, don't they get bored now?
No, because it's how you introduce it, because it's a bit of curiosity, a bit of teamwork, and so on. This is the
type
approach.
of prompts that you're
Yes,
giving to
yes,
them all
yes,
the
yes,
time.
yes, yes. You are keeping them energetic all the time. Yes.
No, questioning, not energetic. Questioning. all
Yes,
the
exactly, exactly.
time. Yeah.
You try to change them. I believe this is the most
Sure.
important. So, now, sorry. Perfect, perfect. But now is the time for the teachers to tell them something new, but very easy. Now the teacher asks them how many command blocks, similar command blocks are there. Maybe it's 9, 10, I'm not sure. Then the teacher can tell them the following. Instead of using 10 similar blocks, we can press the number 1, and from the digital calculator, we can choose immediately 1 to 10. So, and the teacher now introduced children the idea of sequence, that we have a series of same command blocks, and how to make projects more simpler. For instance, this is exactly the same commands. So the teacher introduced them also in early numeracy to learn to count, but also how to think, to reasoning, and make their project simpler. This is also a higher cognitive ability for them, because we are talking about kindergarten students.
So I put 45 and it goes, and then it goes, and it just runs all the
Okay,
time.
okay, so
So that's quite funny.
then the teacher can now tell children that this is exactly the same. We are going to keep this because we want our project to be simpler, but we don't need this one, so we have to erase them. How we erase them? We take all of them and we are putting them here. And when I release my button, disappear. Of course, the children know that if by mistake, accidentally delete something, they have to press the undo button. It's like the same as we're working with Microsoft Word. We have undo and redo button. But in our case, we don't want that. Also, there is a very nice tool, command block here, in the red family. In the red family, there is this one block. This red block is doing nothing, but it's like the same like the dot when we finish a sentence. So the children now learn that similar to literacy, when we are making coding, we have in our coding to have a start and a finish. And the coding blocks are inside. You see now that for a simple example, we have tried to introduce children to coding skills, algorithmic skills, sequence, reasoning, computational thinking skills, but also numeracy and literacy. Because this is what we want in kindergarten and in the first grades of primary schools. But I would want to say that this is hopefully to be the same in all educational levels, but unfortunately we cannot afford that. But it's a good option to introduce children in the early years education. Okay, we have finished the fly. Let's now move and write exactly the same code to other two animals. We are now going to the dog. You see, now I am in the dog. It's empty because we're programming the fly, you see, but not the dog. We are going now to programming the fly, the dog, sorry. So, again, when I press the green flag, I want the dog to do something. What to do? To walk, but not in the same speed like the fly, to see the difference between the animals, because we want one winner. So, I'm going here, I will take from the orange family, I'm going to take this one block, but you see, you remember previously, for the fly, we choose the very fast. Now, I'm going to choose the normal working. And, if you remember, for the fly, we said move 10 steps. Okay, so for the dog, I'm going to take it. I'm going to make again the same, 10. And of course, my code is finished. So, I have to finish it correctly. Just to repeat, we have the code for the fly, we have the code for the dog, the only difference is the speed of the two characters, and I'm going now to programming the pig. Again, you see that the pig is empty, the code area of the pig is empty. I'm going again to put the green flag. Again, I'm going to make the move button, but now I'm going to put the very slowly here, and I'm going to tell again move 10, 1, 2, 1, 0, sorry, and then that's all. Now I'm ready to see what I have done. In this point, a teacher can work with the students in two different ways. The first way is this one. The children to see the whole interface of the app, to see the characters, to see the code of each character, and so on. Let's see that. Okay, the fly wants based on the different speed. The second approach, which many scientists are supporting, that it's also good for the students to hide the code and try to make students think of the code behind the skin, is, look, if we press this button, we can see the app as a PowerPoint presentation. Now the children do not see the code. This is like we call half-baked projects. And we try to ask students, in order to further change them, to try to think, to reasoning, what happened to the animals, and one animal is going slowly and the other faster, and so on. This is a different approach. So, again, the project is fully functional. You see the green flag, but the children cannot see the code, because we don't want to see the code, as we want to ask them to try to think what is happening and how this story was made. So we have two different approaches to work with students. Both approaches very good, and when I work with my students, I'm telling them first at the beginning to work with their students in this way, because you can see that there is a small effect here, so as the children to see how the code is operating, but later on to work in this way, so as to make students think about the way. Okay, maybe here we can further work with this app. For instance, if I remember well, the fly is winning the race. As we know that the fly is winning the race, we can make the fly to say, I win. So as to put the students to learn to write some small words, or even to speak, so as to make the project more meaningful for them. Let's see how very easy it is for children to speak. You see here the green, not this one, the green flag, but this green button. Okay. Here is a recording tool. We can record our own voice. For instance, if I go here, look. First of all, I'm on the fly, because I know that the fly is going to win the race. Okay, I'm going here and I'm pressing this button, and you see this is a recording machine now. And if I'm going here and press this one, the recording button, I win. Okay, I record and stop my voice, and then if I press this button, you can see now that my voice is a command. And I can take the command and I put it here. I think there is a problem with my laptop to send the voice here, but if you are doing that in your mobile phone, you are going to hear your voice. Also, we can make the students write a small sentence, I win. Instead of their voice, I win. Look how they can write. If we go here in the paddle command block, you see here something who says hi. If we go in here, we put it, and if we press this, instead of hi, we can write I win, so as the children to cultivate also their writing skills. So far we have an app, a very simple app, but just try to realize how many different multidisciplinary skills the children have cultivated with just a small app, very, very simple app. I win. So, let's see now what I have created. I have put an extra voice, I win, and also the textual, I win. Let's run the app. Also, it was supposed, if there was a connection, we will hear my voice to say I win, and so on. Also, what is very, very important, and this in many other languages, programming languages, this is something which is very, very advanced topic. It's the parallelism. Parallelism. Something that is happening in parallel. See, with the same event, all commands are doing in parallel. The same event is when I press the green flag, the green flag, the green flag. This is something which is very important and very advanced in programming languages like Java or Python and so on. And this very easily is happening to Scratch Junior. Even this app is oriented for preschoolers. We don't have enough time here. We need a semester to work with the app and to find out all strengths of the app. But before finishing, and left some minutes for questions, just to see how we are making a story, how we are moving from one page to another. This is very, very simple, because if you see here, this is the page 1. You can see that. If I press this button, I am not creating a new project, I am creating a new page in the same project. And each page is completely different than the other. For instance, here I am, okay? And I want now to make a different story. I will think something. Just I have to press this one. You see, a different skin. And I can make 1, 2, 3, 4 different pages. So a child can create a story like a book, but only with 4 pages. And the reason is, if I remember, I mentioned that, we don't want the preschoolers to have extra cognitive burden. We just want to do as it needs for them. 4 pages for them, it's okay. So, here, for instance, I can make, this is the second, you see, this is the first page, this is the second, this is the third, the fourth. You can see the number of the pages. And this is the active page now, because you can see the orange rectangle. Perfect. Let's try to find out how is becoming the transition between the one page to another. So, to realize the transition, I'm going to do something very simple. For instance, here I'm going to put this one, this background in this page, this background in this page, and this background in this page. Okay, just to see the 4 different pages. How I'm moving from one page to another. It's very simple. If I am here in the first page and after the race stops, I want to move to the second page of my story, first of all I have to think, and this is also very important for the children to think, how I will make the transition from one page to another. Some children might say, my students also make the same mistake, that when the fly finishes, I will go to the second page. But this is wrong, because the fly finishes first. So I'm not going to see the rest of the animals. So I have to wait for the pig to finish, because the pig is the most lowest animal. So I'm going to the pig, and before that I'm going here. And if you remember well, previously in this category there were only these 2 tools. Now we have also these commands. Each of these commands represent a different page. So if I want to move from the page 1 to page 4, I will take this one. So there is no need to make something in sequence. I can take and move in which page I want. This is very flexible for the students to make stories and to modify them. But in our example, I want when the pig finally finishes to move to the second page. And now realize that this tool is not needing anymore. So I have to delete it. Because I'm telling my students that when we are programming, We don't want to leave unnecessary command blocks because this is bad. It's the same as we're writing and we're leaving some words alone. There is no making sense. It's exactly the same. Again, the connection with literacy. And let's see what's happening now. Again, you are here and we have the transition to the next page, and from this page I can also put code when something finishes, move to the next page, and so on and so on. Okay? Do I have time for something extra or
Now
no?
you got 10 minutes.
We need 10 minutes for coffee.
Okay, I'm going to stop because as I told you, although this app is for preschoolers mostly, you can see there are a lot of things you can discuss here.
Can I ask this ABC?
Yes, this is also very important and very easy, so we are going to discuss it. This is another way to introduce our students to literacy, because in this way, for instance, when we start our app here, we can also write here, and we can go here and choose how big will be the letters and also the color of the letters. For instance, if I put it here, it's also a different approach as a title for the app. So as the children, again, to write some simple words to express themselves also in literacy skills instead of the other skills. And of course, a child can move it everywhere he wants. Also, if we want the children to learn about coordination, we can use this tool, and the children now learn that each animal have a specific place in the grid, so as to learn about vertical, horizontal, and so on. This is what I'm telling. This app has a lot of opportunities to work with students, even they are university students, but not familiar with coding or even with preschoolers.
Additional question. Is it possible somehow export it?
Yes. I forgot that. This is very, very important because around the world during the pandemic, most of the teachers who knows that this app work with students at home. Why? If you open your app, you can see here this small button. Just press it. I'm going to do it also in my app because the app we are using here in the PC it's a bit difficult. It has a different approach, but I'm going to see that. Okay. And also this is another tool to realize how good app is this. Okay, so for instance here I have done this app. I'm a children, okay? I want to send it in my teacher. I'm pressing this button, okay? It's exactly the same like this one. But if you see, here for us in my Greek version, sets here for parents. For parents. If I press this button for parents, you can see here, the app is asking me something. Ask me to confirm how much is doing 71 plus 1. Why is asking that? Because the app thinks the following. This app is using by a child, but I want the parent to start sending emails to the teacher. So here I'm going to answer, I hope correctly, 72. Okay, and now, I don't know why, here you can see an email. I can I don't know why it's not working now. If I press this, manage to press this, yes. Okay, it writes me now where to send it. If I choose Gmail, for instance, I can write here the email to the teacher. Here you can see there is the name of the project, project5.sgr is the file name of the project, and here is a ready-made letter that this is a project made with Scratch Junior. So I have only to write here the email of the teacher, the kindergarten teacher, and the kindergarten teacher is receiving that in her email. And this is the reason, how during the pandemic, the kindergarten teachers or the primary school teachers communicated with the students when the schools were closed.
But maybe the question was different. It can be open only in Scratch.
Yes, Scratch Junior.
But it's possible to produce some independent file?
To open it with another app and so on?
Yeah.
Yes, I have searched, and there is an app that you can use and create executable files.
Yeah.
So they open with just a click.
Some move or some...
Yes,
something like
yes,
that.
yes,
Okay, thank you.
Yes, but also this is very important, although I did not understood correctly the question, how a child can communicate the project with the teacher is also very important.
It was your
But this was a good answer.
Yes.
Okay.
We can do also there in the app for laptops or desktops, but it's a bit more complicated. It's not worth it to spend more time instead of coffee.
Sorry. Sorry. No, it was very nice.
Okay, so thank you. Is it Professor Doctor or Doctor Professor?
Just Papadakis.